0625 June 10th, 2025 right now marks 1061 hours of progress on the global harvest simulation, and a pretty interesting moment, as it would appear that the code from the 3D physics book introductory section, the math libraries, have been made to correctly output values pertaining to a left-handed view matrix and a left-handed projection matrix, and those seem to be confirmed to be working accurately, as the code from the 3D physics book, which was modified, those 3D math files are outputting the same values as the custom 3D math library, which was made about a month ago. This custom 3D math library creates a view matrix and a projection matrix, and it's confirmed to be working as in the custom DirectX 11 project. A camera is able to be created and an object does in fact show up, and there's a field of view slider that is working accurately, and the object's scale shows up, and the rotations appear to be working, and it's working as expected along each axis. So increasing Y moves upwards in the screen, and positive Z moves forward, which is the intended behavior for a left-handed model view projection matrix. And this is actually kind of interesting, because the actual 3D physics book only originally had code for OpenGL and Vulkan for creating projection matrices for those, and so this code had to be modified and to work with DirectX. And so now that this is working, it appears that the intention going forward is to continue through the 3D physics book and actually get the physics system working. Well, actually, even before that, this new code from the 3D physics book's introductory section, which has been modified to work with the DirectX, needs to be actually integrated with the custom renderer in order to actually prove that this is working right. The values are correct, but it also needs to be integrated with DirectX, and yeah, so these values do look correct. The only minor difference here is that the value at that point seems to be slightly one decimal place higher than it is in the other implementation, which could just be because they use some slightly different math functions, as this does all of that, and over here pi, instead of converting to radians when passing it in, those are calculated there, and something apparently different is going on, as this appears to be the same between them as far as calculating the x scaling and y scaling, but for whatever reason this value here is just a bit higher, possibly due to division, whereas with the other one it's multiplying by an inverse. So that appears to be a correct model view projection matrix for a left-handed renderer being added as functionality to the 3D physics code. What could have been done is to just follow the 3D physics book directly, as it uses Vulkan as a renderer, but the intention was actually integrate the code with the custom renderer in order to learn how to separate the concept from its implementation, which is the best way to learn how to get the functionality working in the minimum steps necessary. So the intention going forward is to integrate this with DirectX, and then looking into adding the rest of the code for the actual 3D physics in order to create a custom 3D physics engine within the from scratch DirectX renderer.